start. So, yeah, first of all, welcome to our webinar on ChatGPT, Midjourney, and AI in the value creation process. So either we already talked a little bit, but for everybody who has just came in, everybody wants to dig a little bit deeper in knowing who you're going to listen to and hopefully talk to later in the Q&A. We want to give a short introduction on today's speakers. Therefore, we'll give over to Marcel and Oliver to introduce themselves shortly. Marcel, you have to unmute yourself shortly.
You also muted me. That's a shame. That's okay. Hi everybody. My name is Marcel. I am here the director at the Center for Deep Tech Innovation. I have my PhD in trust over business processes, and I'm specialized on distributed ledger technologies. Well, that's where I got my PhD in. But I've been working on AI since the deep learning craziness from 2014. So it feels like I'm getting old. It's already 10 years since then. And I've been following the field and worked actively in research, academia, but also in the industry on AI topics. And I will be talking today about the general introduction and a little bit about the insights on how these things actually work. With me is Oliver. Ollie?
Yeah, hello, I'm Oliver. I'm mixed background in between. I come from the German tech belt. I worked for some big companies in Germany, Mercedes, SAP, Bosch and others, and also startups. I also spent 12 years in the US, 10 in Berkeley and Silicon Valley. Did my PhD there, was actually probably the first economist who quoted Jeff Hinton, the father of deep learning. In that regard, and then after my Silicon Valley time, I spent 10 years in Berlin, in the Berlin startup scene, working with technology startups there. Now I moved back to German tech center in Karlsruhe. And most of my stuff I do is I connect technology with an economic understanding and also, of course, a social understanding, which basically comes with a problem of how to deal with new technology, how to put new technology to good users. And we'll be talking about how to take a tool that's very new and how to actually put it to use in your workflow and try to avoid the mistakes that are inevitable and produce good outcomes in any form.
Okay, so maybe I'll take over. A little bit of insights on who we are. We are, well, basically 7 PhD level consultants at the Deep Tech Center. As you can see, well, covering a plethora of expertise and technologies, from blockchain over climate tech, and of course also relating to AI. Therefore, maybe within the next slide, giving you a short introduction of what we do. Basically, we can cover the whole package for you, starting with consultancy on whether a technology should be used, how it should be used, which technology to use, giving general as well as deep dive workshops up to, well, working out a solution and implementing it for you in the company. So basically, everywhere within, well, this service rectangular, we can offer you different services as you want to. And of course, maybe here a little overview of what our core technologies are. We focused on, of course, climate tech, IoT, also blockchain, and, well, the last one here being said, of course, AI, which is going to be the focus of today's webinar, and with which I would give over to Marcel again to, well, dig deep into everything related to AI and ChatGPT.
Great. I will give you folks first a very short overview about how generative AI works. Don't worry, nothing too technical, but I want you to understand the concept because that's important to know that as a background for the value creation processes and how to use it in your organization. And as a third part, Oliver will talk about these organizational changes and the possibilities that come with this new innovation that is currently disrupting everything that we know. And the last part will be then the Q&A. And this is exactly where I want to start. We talk today about generative AI, ChatGPT being an instance of generative AI and will be the example that I will be talking about most, but it's generally a zoo of different things in the field of generative AI. But please remember, not all AI is generative AI. There has been scientific research since the 1950s. And we have different groups of AI type of applications or workings. Like in the 80s, the first was the first breakthrough of the first methods for optimization, simulations, modeling, and predictions. Lots of that in the typical supply chain setups with modeling and with forecasting. A field that had a second breakthrough in the 2010s when deep learning actually became a thing. And it's going to be a recurring theme also across other groups of AI that we have, for example, clustering over here, which is basically grouping data points together, customer segmentation and the like. First proposed in the 60s, breakthrough in the 90s, and second spring with deep learning in the 2010s. A recommender system, something that you folks probably all use on a daily basis. If you use Netflix or Spotify, you see it every day. New movies that are being recommended on you, or if you're even on Facebook and how your timeline is being built, is also the principle of a recommender system behind it. There's other types of AI more in the in the factory settings with anomaly detection, and that has also seen a bump and a boost in its development in the 2010s. And the latest, group of AI, so this is of course incomplete, I just want to highlight it here, is generative AI and what we'll be talking about today. The core breakthrough that enable generative AI as we know today are deep neural networks and hardware that is able to handle them. There's a bunch of different theories for neural networks that were around already for a good of 30 years, but we never had really the hardware to do it on the scale that it was useful until that pivotal point in the mid 2010s. And also around that time in 2014, 2015, there was first experiments on AI and learning patterns to create new images and text from something that a computational model has learned before. And the real kickoff for what we know today in the ChatGPT and Midjourney is a concept called the transformer model. Transformer models were first proposed in a research paper in 2017 and are basically learning on one specific data set, certain features, to produce completely new content from scratch. One of the early applications that I actually worked on a couple of years ago was generative AI with style transfer. So you could upload a picture of you and your spouse, and it will tell the AI, paint that for me in the style of Van Gogh, and it would actually do it. The quality initially was not really what you wanted to have, but that changed over time. There were new developments, for example, GANs, generative adversarial networks, that improved the content or the quality of the content by having not only the trained model, but also having another model comparing it to the real world. This principle we will later see again, for example, for ChatGPT. And ChatGPT uses today, or is built on top of what we call generative pre-trained transformer, or GPT in general. And there's GPT 1, 2, 3, 3.5, ChatGPT, and now 4. And that's the first, or ChatGPT 3, GPT 3 was proposed in 2020, beginning of 2021. And that's where all that started together. You see here on the right side, there's a ton of different large language models. That's how the non-branded term of these things are. And some of them build each other. So this here is really like a lineage, a heritage tree and how the family of generative large language models looks like. Now we know where these things are coming from, and now we would like to understand a little bit what are the key concepts behind generative AI, so we can think about it, how we are using it in our organization. And it's three main concepts. It's maths, it's modeling tokens, so words in a text as numbers, and it is predicting which word will come next. I say now words, but the same principle also holds for generative images in a similar way, but I would just take that as an example here. Maths, I'm not going to explain you the depth of it, because honestly I would take more than an hour. But think about it, maths has a concept of a function. A function has an input and an output, and is doing something to create that output from the input. Yeah? If you want to draw bubbles, we have a green bubble here, that's an input. Here is a function that does some magic, and here is an output. Yeah? And the magic here is really simple. It's just, if you put in here 2, you get out 4 plus a square. Now I would like you to think of AI as just a complex function that is adjusted over time by training data. And that function, we could also call it a model, has the same characteristics like the simple function. It has an input, has an output, but what happens in the middle here is just much more complex. Yeah, you have your inputs here again in green, your outputs again in black, and there is a lot of different things how you are computing and what is happening in between. If we call these things not bubbles, but when we look at it, how they are actually structured, they visually look a little bit like the things that you have in your brain that are called neurons. And that's why in AI speech, this is called a neural network. And what happens when we are talking about AI, we are usually training a neural network based on a test set and a training set, to create the most accurate model. Again, it's a simplification. There's clustering and other things too, but for now, let's start with let's go with this simplification. Each of these neurons or each of these inputs here has a weight, and each of these connections between the neurons also has a weight. And by looking at what is the input and what is the output in a test set, we can calculate an error and rebalance basically the formula, the function, until it gives us a very good output for stuff that it probably it hasn't seen before. And this is where artificial intelligence gets its intelligence from. So it is maths, but it's maths that is trained. There is no consciousness in AI. There is not an overlord that is telling your ChatGPT what to do. It's maths, it's statistics, it's error calculations, and it's training. Please keep that in mind, that we are not running in a different direction. Now, okay, we talked about this is a neural network, there's numbers, but what the hell do I do with text? Well, take this text here, the cool penguins live at the South Pole. We do something that's called tokenization, which is, if we oversimplify it, basically interpreting each of these words that we have in a sentence as a token and giving each unique token a unique number. That could, in theory, look something like this. You will see we have here 1, 2, 3, 4, 5, and then we have the D again, and the D of the in front of the cool penguins and the D in the South Pole are the same word, so they have the same encoding. And what all of these deep learning models and generative text models are doing, they're basically predicting the last word in the sentence by looking at the first part of a given sentence. And that is exactly what we talked about initially with a neural network. You get your input in here, you get an output over there. Then you compare it to the output on your training set, you calculate an error, and you are retraining and rebalancing what is in the network. I don't want to go deeper onto that. It's an oversimplification, but the gist of it is statistics, error, and training behind it. When we take ChatGPT as an example, they do exactly these things. It uses GPT-3 or nowadays GPT-4. You give an input a piece of text that we call prompts, and ChatGPT is predicting the next word and is doing that in sequence to give you the next word and the next 3 words and the next 5 words until you have your paragraph of what it's. And it can do that because it was trained and it has seen data, and it has seen data that is in billions and billions and billions of tokens that comes from, for example, the internet, from Wikipedia, from books, and from other sources like online discussion forums or so. The company behind ChatGPT, OpenAI, was using that data, crawling that data, and training a deep learning model on top of that. We had Ray asking earlier for biases. Well, yeah, these large language models have biases, and that's because they are only in the end using what they were fed as an input. And when you put in a prompt, what a GPT-3 or a ChatGPT or GPT-4 basically does, it is taking your prompt as an input, is predicting which are the next words or what is the probability of each word or of a certain sequence of words. And think about it, you take the top 6 answers that you get, each of them have a certain probability, and then you roll the dice, and it's not an equal dice, but it's a dice that is a little bit crooked and is giving you with a higher probability certain sides. And this is where these models are trained on, and where we can also influence these models. There are so-called hyperparameters, where you can, for example, tweak these models to give you especially creative answers by adjusting the parameter called the temperature, or by looking only at the top answer, or by looking at few answers. More advanced stuff, nothing for today, just to understand that this is basically the principle behind it. When we look especially on ChatGPT and how that works, that neural network training and that model training was the very first step that they did. But there is a human in the loop, because just by training on what you see on the internet, you might not get the highest quality. And that's why they introduced a 2-step approach to fine-tune these models. So we think in the first step, you do exactly this prediction. You give a prompt and you have an answer. And in the first step, you not only do that to your model, but you also do it with a real human being. And therefore, OpenAI used contractors, where they're saying, here's my prompt, answer this prompt for me, giving information that you can retrieve. And they did that several thousand times. And with that, they had basically a set of prompts and answers that were created from real human beings, and a large, bigger set of prompts and answers created from their machine learning approach. And they gave the model basically the input from the human input, and let it fine-tune it and learn from the human input to make the model more accurate. And the second step in how ChatGPT was created, the researchers created basically a comparison model and a reward model behind that. And they were basically giving ChatGPT a bunch of different prompts, and then a labeler, so a human being, had to sit there and rank the 10 different answers to the same prompt. No, I think it was 7 different answers to the same prompt, sorry, in what they think is the best answer. And based on that, you have a score, how good your answer is, and you can train what they call a reward model that your model is then taking in when it comes to looking into something that it doesn't know. And this reward model is then basically used as a policy when you are interacting with ChatGPT and it creates an answer for you. You apply the policy, it generates an output, and in the end, how good the output was. And that's how ChatGPT fine-tuned basically the machine learning data set. And now it also fine-tunes it, by the way, by the input that you give it. So in the beginning, actually, OpenAI was hiring contractors to do this labeling. Now they just take the answers. When you tell ChatGPT, no, this was not the answer I wanted, they take this and learn even further. Also keep in mind for the ethics and for the legal discussions in your company that you might have. This was a long story about how these things work, and the important thing that leads all to the four important things here, and that's the limits of these type of applications. Large language models like ChatGPT are terrible in citing sources. It's just, by the way, it is taking sentences, taking tokens. It's not taking, reasoning behind, okay, this is this book, this is that book. That's not how it works. And that's why it's so terrible in citing sources. Biases. Of course, you have your model can only output what it learns. Yeah, it doesn't have a consciousness, but it was trained on a large data set. And if it was, for example, trained on something like forum blog posts or so, there is always a bias in the data that it was trained on because someone was writing that in the end. And it also learned that, of course, there were some fine-tuning to get some bias out of there, but sometimes we have seen some, ChatGPT created hate speech. That's not because it's a hateful piece of thing, it's just because math doesn't know better. And that's also the point for the third point, hallucinations. Sometimes when LLMs do not know the answer or have an unknown question, they just make something up. Yeah, because for them it's just as much statistics as anything else. And where's the difference for it? And because it is basically a prediction, a statistics engine, giving mathematical problems it's sometimes a little bit difficult to them. With the newer versions of ChatGPT and GPT-4, this is solved a little bit, but again, it is applying patterns, and sometimes these patterns are just incorrect. And when we use that in our organization, we build our processes around something like that, we always have to remember that we have to be very careful of what we get in, because that determines the output. And that's exactly the beauty of it, and where it becomes engineering again. These models are powerful. You can give the ChatGPT a context and tell them write something about it. You can ChatGPT tell to write from a different perspective. For example, act as a teacher, write as a doctor, write or use a different style, write in the style of Goethe. And there's more advanced techniques like chain of thought, discussing with these models, zero-shot, few-shot prompting, self-consistency, all stuff that we can't go into today. But what I want you to understand, that using a large language model and get the output that you want is a non-trivial task. And it's a skill that you can learn. And there is now also a term for it. What this discipline is called, it's called prompt engineering, creating the best prompts to get the best outputs. And currently, because it's a high topic, people make a lot of money doing prompt engineering, even though it's a skill I believe that most of the people who are here today can learn without any issues. More on prompt engineering later and in our follow-up webinar. And now let's talk about the real part that we understand now, the basics. About value creation processes, and especially how AI helps you or acts in it. And therefore, I would like to give you a very simple example. This is a garage. Think about you recently bought a house, but you don't have a garage, and you want to hire an architect to make a blueprint for your new garage. That's a quite complex business process behind it. And I modeled, a simple version of that business process here in a diagram. And that would be here, you as a homeowner, you want to get some blueprints for your new garage. You make an inquiry at an architecture firm, an administrative assistant is receiving that inquiry, and extracting some key points on it, the short version, not your long letter. This is giving the short version to a project planner. The project planner makes a cost estimation that then the assistant is sending out to you as the homeowner. You either accept it or reject it. Then there are some automated processes with getting stuff into customer relationship management tools, sending out documents that can be done by company or by the IT infrastructure of a company. And then you have, in the end, somebody needs to go out there and look where you want to place your garage and take measurements. And that's a manual task. You can see that here with the small hand. This field worker afterwards draws then the boundaries of the place where you want to put your garage in a CAD software. The project planner makes the very first plan, and that gets then sent to the homeowner, and you iterate over it until it's good. Why I am talking about garages when we should talk about ChatGPT? Because I want you to understand that there are basically 3 types of tasks in any business process where you can use or not use AI technology. The first is computer-aided tasks. Yeah, these are tasks like the administrative assistant extracting the key points from the inquiry that she gets. In computer-aided tasks, it is possible that you can use AI as a complement to your existing task. So the assistant could sit there, paste the email into ChatGPT, say, explain it to a 5-year-old and give me 5 key points and give it to the project manager. Could also be used to improve originally created human content or in many other ways. Or it could also be used in the synergy with the typical topics that you have in digital transformation, with process automation to get rid of the human in the loop completely. But that really depends on the specific business process and the task that you have and how and if it works with AI or not. Then you have already fully automated tasks where you already have an existing automated workflow where you can use generative AI to create some text, improve the quality of outputs, or put it just in a more human-like form. Has, of course, synergies with process automations. There's a lot of people that are currently using the ChatGPT version with Zapier, which is a process automation tool, which I find very ingenious and is quite a lot of things. And then there is the last part, and these are the manual parts. In our process, this was the field worker going out and taking measurements. There ain't no ChatGPT helping you with that. You cannot. ChatGPT lives not on 2 feet and doesn't do measurements outside. At least today, not without the hardware. And these are completely physical tasks. And for many of those physical tasks, AI will not help you a lot directly. Indirectly, maybe, but not directly. And there's also tasks that are non-digital, and also non-physical. Something like you make a sketch on a piece of paper. This is, of course, then a different situation where you have more of a digital transformation, digitization topic, where you can, of course, then use AI as a complement in that value creation process. And with that, you can basically qualitatively think about what is needed in your process, what are the tasks that you're doing, and you can look what these generative AI tools that you have that are currently out there on the market can do. This is a nice picture from I think from Sequoia, with the source in the appendix, where you see the landscape like it was a couple of weeks ago. It's rapidly changing anyhow, but you have basically core groups of generative AI. There is generative text, ChatGPT, best example for it. Right now, very advanced, you can do a lot of things with that, viable use cases across many different things that you can do. Something where I would recommend anybody who says, okay, I want to take my business to the next level, get your hands on, try something out, learn it, and look how you can make it in a legal frame, in an ethical frame, and in a technological frame work in your processes. That The same holds to the most part also for AI-generated images, even though when we look at Midjourney, which is terrible at creating faces or face-like human expressions that do not scare the living mess out of you, which is not so good, but also improving that. There's a lot of viable use cases right now for generative images. We had earlier the discussion about generative code. This is one of, according to my experience, one of the fields where the absolute early adopters get so much value out of using these code tools and just speeding up workflows with stuff like GitHub Copilot, or you can even ask ChatGPT to program for you. Two things that are on the generative AI tool landscape, but are not too advanced yet, or let's say semi-advanced, you can also use it sometimes, is generative speech and generative video. Just the complexity of that is just a little bit higher than you had it with text. When we talk about our value creation processes and we talk about who is carrying out these value creation processes, you have always employees. And I wanted to show you this nice graph that I got from Goldman Sachs, their investment research arm actually, talking about what industry here on the x-axis is and how much tasks that you usually do in that industry are prone to no automation at all. That's the dark blue one. Are tasks where you work with an AI complement to help you and support to support you and get more efficient, or where AI will completely replace certain workflows. And the left side, you see the things that have the dark blue things. These are things like building, grounds, cleaning, maintenance, installation, construction, production. They have a lot of physical tasks where, you know, no generative AI will help you in the end. On the other hand, you have the computer engineers, you have education, you have social services, you have sales, where a lot of the tasks, they at least predict, will be at least complemented by AI. And then there is a few industries, or let's say a few types of activities that can be completely replaced in a certain industry. And they are predominantly in legal and in administrative support tasks. So people doing office administration and so on. And that's their prediction. I kind of have a feeling that that sounds about right, but how it will turn out in the future is up to the future. And now is really the question. I mean, you folks came all here for a reason, and you are probably all interested in trying it out and maybe implement it in your own organization. And this is where we'll hand over to Oliver and how you can tackle this beast and become of one of the early adopters or even disruptors in your field and make real impact for your organization. Ollie, floor is yours.
Thank you so much. You can go back. It's slide before. Because I wanted to start with an anecdote which came back to my mind a couple of months ago when I first started using these tools. And I went to an exhibition of the famous French Impressionist painter Edouard Manet a couple of years ago. It was pretty big. It was like a career retrospective, and so they had a lot of his paintings, some of his lesser works too. And there was a portrait of a woman, and you could see it was impressionist means like very quick brush strokes, can do like very quickly create an impression of the human figure, and this is why, of course, impressionist painting changed the world, make it much faster to create an image of a person than the naturalists that came before. And but this particular painting was very strange because the face was really well painted, but the hands looked horrible. Their hands looked like basically a mess of brushstrokes. So something must have gone wrong, and Edouard Manet understood it and put it aside, and it never really appeared in the normal exhibitions, only in just this one. And that recollection came back to me when it became clear that the first visual tools like Midjourney and DALL-E started creating lifelike or painting-like images, but they tend to get the hands wrong. So hands seems to be a problem. We're not really as good as creating an impression with simple terms. So this is basically brings me to the question: is like, okay, like if I want to use this tool in my future workflow, where can I put it? How can I use a tool that creates often plausible results? Sometimes it creates results that are plausible but wrong, and sometimes it creates results that are obviously wrong. Famous examples is very like a GPT tends to be very wrong at very simple math problems. But then again, the bigger problem might be that it sounds right but is wrong. So how can I use a tool, a knowledge repository that is not entirely reliable and not trustworthy, but I still want to use it because there's very clearly a lot of knowledge I can put to work for myself. And if that sounds familiar, the question sounds familiar. I think we had very much the same question around like in 2007, 2008, when Wikipedia blew it up and everybody, oh, this is not as good. It's not as good as an encyclopedia as the traditional ones. But then again, over the last 15 years, we just started using Wikipedia. We understood that it has its limitations. We're not entirely trusting everything that's in there, but we can normally check, do double check if it's right or wrong. And this question is like when those tools started being in private beta, I think especially GPT-3, OpenAI basically asked academics in a variety of departments. First handed that to natural sciences, like, okay, can you use this tool? They think it's helpful. And they come back, oh no, it's all wrong. Everything it comes up with is wrong. It's really not reliable for us. It doesn't help. And of course, then I handed it over to the business school. The business school, can I have this right now? Why? Because it's very much clearly a tool that gives you an opportunity to reduce your workflow, to use human workflow if you put it to the right use. And so now we can go to the slide, basically how to deal with this. And this very much comes like, this is not the first time we deal with trying to automate something. Of course, we're trying to create an autonomous tool. We've done this before. Typical example is, of course, autonomous driving. How can we replace a human effort? How can we replace a human driver with a machine driver? And of course, both can get it wrong. Humans make mistakes, machine makes mistakes. But at one point, we have to come up with a way to create a handover. And the way autonomous driving research solved is basically come up with a multi-level system, right? Basically, first you give the machine an easy task, and then a little bit harder task, and eventually there will be a point when the machine is better at driving the human. And we will not get this very likely. We might not even get it in autonomous driving, but we will most likely not get it in a normal workflow. But of course, we want to get to a point where we say, okay, it's actually reducing my effort without reducing the reliability or the quality of the output. And this is sort of like the starting point. Like if you think about like which are the tasks where can I put to good use, where can I actually produce better output than I have now and can do it faster, is I call it the 80-20 rule or the Pareto rule. If you find a task where machine is able to do 80% of the work and you spend 20% of the time proofreading and correcting, you're actually at a point where you can actually put it to use. And over time, if you find these, the 80-20 will move to more 95-5 or 99-1 or maybe even like 100 and 0. And so which one could they be? And this is for the next slide. And this is already basically handing over to the Q&A. We'll come right after. And for you, the opportunity to think about tasks in your world, where it might fit in, or maybe we can help you with a couple of ideas. And so have an interesting discussion, hopefully, about like which are the tasks where it makes sense to put a tool in like this in place. And so we came up 4 categories where it makes sense. First one is very much pre-selection task, is very much sifting out the clearly not qualified, coming up with preliminary rankings, getting ChatGPT or other tools to provide options and provide a preliminary evaluation, and then you as a human with more domain knowledge can start with this and focus on the critical cases where you have to put more effort into deciding if that selection should be in or out. And this is like many cases where you start with a population of 1,000 or 10,000 cases, and you want to go down to 20 or something. So this would be the typical case, like where you have human machine effort first, and then human effort second. And then purely creative tasks. This is much more for the visual tools, of course, but of course we also use ChatGPT and other text-based tools for producing creative materials. This will be over time. This will be a major source, and of course, Marcel already mentioned it. There will be a lot of conflict over copyright, over derivative work. How much does the machine created result, a machine created artifact resemble a human created artifact where a human has a creative right over it, a property right over it. So this is basically would be the task you have to do afterwards, either by doing a Google image search or a similar task to make sure, or use any of the open source generative AI tools that come out that are actually only trained on publicly available, public domain source material. This would be number two. Number three is easily correctable tasks. And code production in that fits in there, especially low code. Marcel mentioned it. If you have a simple script for something you do like every time you do the same thing. I go from Word to PowerPoint and then to some other tool back and forth, and I want to script that. And then basically you can ask any of the code producing AIs to do that. And of course, usually you find out very quickly if the code works or not, and if it's simple enough. I think we're at the stage where code works quite reliably. So this is something where we actually at like 90 and 10 and not at 80 and 20. And then the last thing is very much an error tolerant task where the humans make mistakes, the machine makes mistakes, they don't really differ by that much. And so basically error proneness is worked into the workflow, and we deal with that because we know we can't get it better. And we expect, of course, like all of those tools are moving at a very rapid clip, and they tend to get much better very quickly. This is what we expect. This is also why we're focusing on. So this would be sort of a basically 4 categories, and thinking if you have use cases you can think of, maybe we see if we can fit them into one of the brackets, or we can, of course, come up with a recommendation, maybe wait a little before you actually use those tools, or don't use them in production yet. Try them out, see what they come up with, and see if you're still better, if your human effort is still better than the machine produces. But we're still pretty far away from autonomy. So the first, and Marcel mentioned, the first one is most likely code. All the others will move back. Creative tasks, of course, we're very far, with the caveat that there are still unsolved problems about the copyright. Yeah. So before we do Q&As, Marcel has another announcement.
Yeah. So guys, or folks, we are now at the Q&A part. Before we go into the Q&A and everybody is leaving part by part, I hope you enjoyed this webinar. And if you would like to get this path further with us, there's a couple of ways how you can directly interact with us, or how we can help you in, let's say, a low commitment type of way. For example, we have a weekly newsletter, not your typical here are 3 prompts and nothing else newsletter, but a newsletter for managers, for executives, for leaders, to stay ahead of this rapidly evolving field. We have a dedicated team who's doing nothing else than looking into what is currently on the market, what is happening, and putting that into an easily to digest form. It's a paid newsletter. We spent a significant amount of resources on it. You can get it today at 20% off on our Substack. If you want that, please feel free to scan this QR code that you have here. We'll also send the link afterwards. And of course, we will send you an invoice to get that reimbursed from your employer, however you like. Our next seminar that is going a little bit in a more deep dive direction is at the 14th of June at 4 p.m. Central European time. So that is 10 a.m. East Coast and about a bit earlier in the morning at the West Coast, right? 3 hours more. If you want to be part of that and you don't have time, no worries. You can also have a recording, or we can make a specific prompt engineering course for you and for your company. But we will dive there deeper into, how to create these prompts, how to steer your organization towards doing all these tryouts. Also, offer code if you subscribe today, or if you buy a ticket today, you get 10% off. We have what we also do is work together with companies like your employers as experts to disseminate some knowledge or to do these tryouts that Oliver was just talking about. And of course, there will be also another next open webinar. Subscribe to our channels and especially on LinkedIn to not miss anything. So we haven't lost too many people during the sales pitch, Ollies, and we have a lot of questions. So let's go to the Q&A. Guido, up to you. Guido?
Yeah, sorry. Just a short second, I was posting the link in the chat session. Yeah, with Q&As, well, the first question that came up, or the most question came up, was if we're going to share the slides somehow.
Yes, we can. And there is also a recording that's going to be uploaded on YouTube. We will send via Eventbrite a set of links out that you folks can all follow up with that. Subscribe to our YouTube channel. We have also another video coming this week, actually, on the history of AI and how it led there. Very interesting. I just rendered it today, and it will be also up later this week.
Then we have a question with regards to robotics AI, somehow which role, well, they will have in production, like, well, gigafactories and everything that's innovative construction or production sites.
Mm-hmm. Productive AI, I didn't mention, let's say, robotics in the very first cut, because robotics itself can also exist without AI, or there's longer robotics than there's AI, so it's a longer difference. I believe that let's say in engineering type of applications, you will have less of these generative AI tasks that we're talking today, because you need to be there precise. But of course, there's currently models, autonomous driving, just to give an example, that is actively being worked on by any major car manufacturer in the ways of automation. There's also, I think, image recognition in workflows. Yeah, different type of AI. For me, also something that we will see in any type of production within the next 10 years. Maybe also Oliver has some takes on that because you worked in that field, Ollie. Maybe your 2 cents on that topic.
On robotics, you mean, or
on robotics?
Yeah, but of course, robotics also, like a lot of production systems use machine learning for prediction. Generative more like means creating new combinations, which to my knowledge is not really in production environments yet. But I'm pretty sure it will come into play. But I'd be very surprised if there's already an active generative AI robotics in an automotive factory. But of course, they're trying out with prediction. but this is a little bit of a different category than what we're talking about.
Good. Yeah, next question, please.
We have like 3 questions that I think we can add into one text. The first being citation problems with AI, if we think that they're going to be resolved. According to this, also how future AIs will, if they will have problems with content produced by older AIs, so that we're going to have some kind of bias of false informations or falsely build up informations when future AIs then try to connect with the informations that are out there. And well, maybe in this sense also, how credible Google's claim is that they are able to identify AI-generated text, etc.
So on the topic of citing, there are a bunch of companies that do focus on exactly that question of where can you cite, how can you cite that perfectly, and have a little bit of a different model than what currently OpenAI has. So yes, it's actively being worked on. My personal best guess is yes, it's a matter of time that these citations are also going. It's then just a matter of, how powerful will these models be, and maybe on a technical level they will be different than what we have currently with ChatGPT. But generally, on a conceptual level, I don't think there's anything holding it back.
Then we had the question with Google's claim to be able to somehow spot something that's written with AI, and the problem that future AIs will have false positives from all the AIs, all the AI-generated context.
Oliver, up to you. I'm thirsty.
Sorry, which one was this?
Ethics. And Google's claim.
Okay, like Google's claim about if it can spot fake. Basically everything. The thing is, like, we tend to think about like computers interacting with computers, that the computers like does deterministic results. This is a sort of a if-then rules. Once we're in the machine learning world, that is not really applicable anymore. There will be very sure over the next couple of years good enough solutions. I'm not sure if good enough is the right word, but like adequate solutions to detecting machine-produced output. Simply because there's enough pressure to do this. This could be in the form of like digital watermarking, or on the other end, that it sort of recognizes the pattern it creates, or like produce Easter eggs or similar. The example, the comparable is basically when Napster came out, like nobody thought it was able to recognize a piece of music, because piece of music was stored in an MP3, and the MP3s of the same piece of music looked a little bit different. But now this is also done with machine learning, so we have a fairly high accuracy rate of detecting a piece of music, and of course the copyright owner of that piece of music through machine learning tools. And this will happen too, because there's so much pressure on resolving this problem. Companies like Google and also Microsoft, they realize they cannot have a product on the market that is producing illicit output, like high levels of illicit output. This will definitely go through courts, and this usually creates enough pressure on the manufacturers, the producers, to solve this problem. But this is something that will take some time, and we'll have both types of errors, that it doesn't recognize falsified content or machine created content, but it misinterprets human content as machine content, which could be a problem if you're writing your homework. Like you write your homework yourself, and the detection software claims it was written by a machine, and basically accuses you of cheating. So we have quite a few problems with this, and this has to be solved, or otherwise they will not stay in production for very long.
Then we have, maybe to put in a short question, useful tools for coding. Well, useful AI tools to help coding.
For now, ChatGPT, GitHub Copilot, I would say. My personal recommendations, but we have a test on testing exactly that out and giving better recommendations as part of our content that we will be sending out with our newsletter in the next 4 to 5 weeks. Currently, not conclusive yet, but we're working on it right now. Yeah.
Then we have a question with regards if we believe that we'll be getting more efficient through AI, so we don't have to burden resource consumption.
Yes.
Yeah.
Yes. I that study from Goldman Sachs that I've shown you before had a big question on will AI replace us? Will AI steal my job? And honestly, it's less about stealing your job. Your job will just look a little bit different. And it will overall, I think, on an economic level, it will, on a macroeconomic level, increase our efficiency by quite a lot and increase what we are able to create as an output as a society in economic factors. And that's also what the Goldman Sachs researchers on the economic side were talking about. But we have an economist over here. Ollie, maybe your 2 cents on that question.
I was just going to answer it in the chat, but I can do it here too. This is basically, I mean, the maybe data, like massive amount of data center water consumption.
Yeah, exactly.
There's massive stuff happening right now in the open source world to make these tools much simpler and ultimately be able to run on laptops or similar. The big tech companies in Silicon Valley and in Seattle, they tend to like over-engineer, come up with very big tools, like they have billions of parameters. And of course, there's a lot of interest in making those simpler, and they're being pushed now in that direction. So this will resource consumption we expect to drop very quickly. So there's stuff happening, new stuff happening on a weekly basis in that one. Yeah.
And on that note, we have the vision at some point in time to have a decentralized large language model and have companies that collaborate with each other to build these things, not only for the sake of the planet, but also for the sake of a better quality what comes out there. If that's something that you are actively interested in, please send us a message afterwards, because we are currently looking for people to build a consortium to do exactly that.
Maybe I think I have a good question from one of the last one from Phil. He talks about anthropomorphizing. I just looked it up, which is the repeating kind of getting human traits, and in how far as a society, if there's a concern that we will not be able to distinguish from AI-powered things to human behavior. I think this starts by maybe some voice recognition over videos to actual emails and everything. Phil, please correct me if I'm wrong, but I think I got your question.
There is already things of that are completely freaking me out, to be honest. So there is one. I think it's a one company that has an application called photostudio.ai. And you can basically put there a photo model, so someone who would be a Heidi Klum type of thing, who doesn't exist. And you can put your virtual clothes on her and tell the AI to pose in certain directions. And honestly, I cannot tell you that this was AI generated or it was, because it is such human-like. Also for text, my colleagues at the university have problems to distinguish if the text was generated by a student, if they wrote their essay, or if ChatGPT wrote their essay. It's a huge problem, and it is something that I think has a large impact on our society, and where we really have to see on what in the end makes value for us. What is it really about? How to distinguish from what an AI does and what a human being does? Or is it about, it's just different classes of things, and AI will write everything that we do eventually in a certain field or not? So It's a lot of a philosophical question, and I'm not the biggest social scientist, to be honest. But I think this will be a real societal challenge. That's my personal opinion. Ollie, your frown is not upside down.
Everything is going in both directions, the good and the bad, and of course, meaning that we can create human-like content in certain areas that a machine creator creates a lot of problem for a lot of institutions, instead, like universities, an obvious one, where you basically will have to go back to like taking exams with a pen and paper and in a locked environment, so people cannot use these tools. But on the other hand, of course, in the business school, as I said, they're happy to let the students use it. Basically, you have to make clear that your text was produced by a machine, and you have to provide the prompts, but then that's okay. So we have these situations where like things are going very fast in both directions, and I agree this is a key problem to focus on. For not really economists, really sort of like social sciences, sociologists are the ones who really need to tackle. Ethics experts need to tackle these questions. Yeah. The thing is, we can't stop it. The tool is out in the wild. People both in tech companies and in open source are building on those now. Yeah.
Okay. Maybe I have one here from Ian. If we can comment something on the hardware requirements for AI implementation, if there always will be a need for dedicated AI hardware. I think this.
There will be always be a need for hardware but it will not necessarily need to be dedicated. There is already data centers, Google, Amazon, AWS are both offering these training of these models. That's the training of any type of AI algorithm on their hardware. The need for hardware will not go away. At least talking about the deep learning type of things, if someone will come up with a complete radical approach to that, or if we're talking quantum computing at some point in time, then we are talking just on a different number.
I remember a time when it was still like completely visionary to have neural networks run on dedicated chips. And then for a while we had like basically custom built chips. Now we're using GPUs. And it will become more and more like bulk. The more these tools are being used in production environments, the more we'll have bulk hardware available for this. Yeah.
We also have comments on Akasha network, and there are also some blockchain projects and everything. But I think this is a topic for maybe another seminar or something. Yeah, so far, I hope at least that I've covered every question. If not, feel free to ask them or just to drop a quick line. I think
email us afterwards.
Yes.
Yeah.
But at least I have the impression that we covered all the questions out there.
Yes, email address is also here. Our LinkedIn is here. Please. Okay, cool.
Thank you so much.
If there's no more questions, I thank you all for your attendance and an extraordinary amount of people here today. I'm very happy to see that. And if you want to work with us in any way, form, or extent, please come to us. We are always here. Thanks.
Thank you.
Thank you. So with that, we end the seminar. Have a good day. And yeah, goodbye.